Okay, I'm to the point here where I've got the flying leads on the circuit board all in place. Mostly in place. There's some like high voltage wires that I haven't put in yet, just because it'll be easier, I think, to measure the length of those with the board in place. And then some like filament wires and things like that will go in after the fact. But yeah, so where we're at right now, this is pretty much done. So this will get bolted in to the chassis, hopefully for the last time. And then we'll do all of the flying lead offboard wiring. It'll definitely take a while. This is probably looking at like a 6 or 7 hour job to get everything wired up and in place. And then from there, it's the first kind of firing things up, making sure the bias voltage is set high enough to where we're not going to fry the power tubes the first time we plug them in. But from there, yeah, everything should be good to test. Okay, so I finished up the wiring. Just made sure everything was in place. I put the bias supply electrolytics backwards, so I had to go back and take those out and make sure that was okay. But basically everything is wired up. I did just do kind of a dry test fire here, but I'll turn this on and kind of walk you through what I do when I first start up fresh builds like this. Basically, what I've got here is I've just got it plugged in. I do have all of the tubes in there, but typically what I'll do is I'll start this up without the tubes in there, and I'll get, especially when you're dealing with like fixed bias amps, I'll go and adjust the bias voltage into a range that I know should be safe, so you're not going to like burn out the power tube the second you turn it on. And you get a more accurate B plus reading this way. But basically, this is all hooked up, and then I've got this like 16 ohm 12-inch speaker hooked up to this, just with a cable I had lying around. But basically what I like to do is put that all on, turn this on. I've got my meter connected to ground over here. So you turn this on, and typically what you do is, the very first time you're doing this, you use some kind of inline current limiting device. A lot of people use like light bulbs. I don't have one of those, so I just usually turn this on and make sure nothing lights on fire, but it seems to work pretty well. So what I do is I usually go around and check the B plus voltage. It's one of the first things I do, just it's the very first node in the amp. So B plus is here. You want to keep one hand outside of the amp, so you can see it's about 337 volts, which is a little bit higher than I was anticipating, but it's fine. It looks like these Russian tubes are handling it just fine. And then second thing I want to do, because I have a DC power supply for the very first tube. Actually, want to go and check the voltages there. Let me change the range of my meter. But this is the voltage on the tube, so it's about 5.8 volts, which is okay. I mean, it should be around 6.3, but I don't know, I just rounded the resistor values, and it's maybe a little bit more drop on those diodes than I predicted. And then sometimes what I like to do is I like to go through and measure all of the plate voltages. So the first plate voltage be here, be 269, and you can measure on the actual plate itself. So that's 111. So about a little bit over halfway, which is fine. And here's the second stage, 155. So that's a little bit high, but it should be okay. And then you can go in with the on the phase inverter tube, so 180. These are typically pretty high, so, and 190 on the other one. So yeah, that's looking pretty good. So the very last thing you want to check is your bias voltage. So I don't know if you can see them down in there, but on the sockets, basically what I've done is I've wired up current sensing resistors on the cathodes of the power tubes. Those are 4.7 ohm resistors. What that allows me to do is I can, if I'm able to precisely get in there and measure that, what you can do is you can see that's 0.126 millivolts on one side, and then I put another one over here. It's kind of buried back in there, but, and so this is 0.99, it's about 0.1. So 0.1, 0.2. So you can see the power tubes are not well matched at all, which is probably okay. But basically, if we do the math, we know the plate voltage is about 320, and these are 12-watt tubes, so I want to dissipate around, let's say 8-9 watts of power. So that's 8 divided by 320 volts, which means that for each tube, to get to the kind of 70% power dissipation idle power dissipation factor that people typically use, you're going to want about 25 milliamps running through each tube. So that 4.7 ohm resistor is in series with the tube itself. So if 25 milliamps runs through 4.7 ohms, so just 0.025 times 4.7, what we should see is about 0.1175, or about 0.12 volts on those resistors. So you can see we have about 0.12 on this guy, and on this left tube here it's about 0.99. So the right tube is dissipating a little more than the left tube, but it should be fine. It's just kind of an average idle value. As long as we're not over 12 watts per tube, we're not anywhere near that power dissipation limit, we should be okay. Yeah, so let me go ahead, I'll plug this in and we can test it through our speaker. All the voltages look good. I don't need to mess with the bias pot or anything. I actually already did that. But say if those were off, you'd just go in here and you'd turn this until you get the right reading on those tubes. So let's go ahead. We will put this camera down and play a little. Alright, so we've got this guy turned on and plugged in. Turn the master volume up. Might not be in tune. You probably can't see the controls, but the tremolo is all the way down. Tone is about 75% of the way up. Gain is now half. So everything works. There's no like buzzing or humming. No filament hum. I mean, we rectified the first tube, so usually that it keeps it pretty quiet, but this is very, very quiet. It's a little bit gritty. We can test the tremolo. Test the speed, low speed. High speed. Increase the depth. It's almost like a stuttering. Turn that down, maybe turn the gain up a bit. Cool. So one of the things to test here, usually when I plug these in, if the amp has global negative feedback, you want to make sure that the leads going into the output transformer are the right phase. If they're not the right phase, you actually have positive gain in the feedback loop. And that can cause all kinds of weird oscillations. So usually the way you test that is you turn everything down and you turn the master volume up. A little bit of noise here, and maybe a little bit microphonic tubes. And a little. Yeah, definitely microphonic. Something is microphonic. One of these preamp tubes, probably. Oh yeah, that's 6SJ7. Might need another one of those. But it's actually surprisingly quiet, even though I'm getting a little bit of bypass noise. What you want to make sure of is that it's not just oscillating all the time. Usually what that means is that, like I said, the feedback is the wrong phase. So this I think is okay. There's just some kind of high gain oscillations going on, probably because of the way I've wired it, but seems fine, seems good. Yes, very, very loud. It's pretty killer sounding actually. Anyway, okay, so the next step, because this isn't the speaker we want to use, I'll go ahead and mount this in the cabinet, and then from there we can test with the actual speaker. I need to make a speaker cable, but from there should be good, and this amp is done. This build is pretty much wrapped up.